So the first part of this video, I would like to show you how to eliminate a parameter between x and y. So x and y are parameterized by u, and I want to eliminate a parameter. So one way is that I can solve for u in the second one because that's the linear. See, y is to power 1, u is to power 1. They're not multiplied together. So I solve for u, and I get u is equal to y over 2. Then I plug it back into the first one. So x equal to y over 2 to power 2 minus 1. And so this eliminates the parameter u in here, and the resulting equation is an equation of a parabola on the side, sideway parabola going. Second part of the video, we want to talk about functions of two variables. So I have a u in here defined as a function of x and y to be x minus y, and v to be function of x and y as x plus y. Now I want to find the collective reverse of this. So I want to find x of u and v and y of u and v. And how do I solve that? So basically I want to solve for x in here by eliminating y, and then solve for y by eliminating x. And that's the goal. Here, let's see. This is, let me rewrite this. Maybe this basically make it more clear. In this very situation, I have two linear equations in terms of x and y. And let's say if you set up a linear equation, on the right side, you should have a constant. Here you have some other parameters, but it doesn't make it any different from solving any linear system. So what I do for linear systems like this is I add the right-hand side together and the left-hand side together to eliminate y. And so I get in here by adding and adding, I get 2x is equal to u plus v. And therefore x is equal to u plus v divided by 2. And then I rewrite this again, x minus u equal to u, x plus y equal to v. And then this time around, I subtract. And so here becomes minus, minus, and minus. So when I subtract, I get x minus x, which is 0, minus 2y is equal to u minus v. And so y is equal to v minus u, divided by 2. So going back in here, I can write as v minus u divided by 2, and u plus v divided by 2. And u, v are very much alike at this point.